All right, so we are on the 2018 exam. We're looking at question number 1. So people enter a line for an escalator modeled at a rate by, and they give this R of t function that's a piecewise function. So from 0 to 300 seconds, people are getting on the elevator, or what is an elevator? Escalator. People are getting on the escalator. And then at 300 seconds, the rate goes to 0. So no one else is getting on the escalator after 300 seconds. So they're only getting on from 0 to 300. And then it says people are exiting the line at a constant rate of 0.7 person per second. There are 20 people in line at time 0. This is a rate in, rate out problem. They always have one of these on there. It's like guaranteed to show up. So letter A says, how many people enter the line from 0 to 300 seconds? So we just want to accumulate people from 0 to 300 R of t dt. And so that's easy enough. What's tricky is typing it in the calculator because the function is so nasty. But it is going to be math 9, 0 to 300, and then that function is 44 parentheses. It says t, I'm going to type x, x over 100 to the third, and then another parenthesis, 1 minus x over 300, and then that is to the 7th. So like the idea of what you're supposed to do for the problem is really not bad. You're just accumulating people, but then typing that in is just a nightmare. You type that in, you should get 270. So 270 people get in line from 0 to 300 seconds. And I know I typed that quickly. I'm going to keep going to make sure that we get through as much as we can here. So if you didn't keep up with the typing, you can always watch the video later. I just want to make sure we get through as much as we can. All right, B says, during the interval 0 to 300, there's always people in line. How many people are in line at times 300? So we just said 270 people got in line. We need to add on what we started with. So it said there were 20 people to start with, plus the 270 that just entered the line. And then people are leaving at 0.7 people per second. And we're doing this for 300 seconds. So this is what we started with. That's the initial condition, plus how many people got in line, minus how many people got out of line. All right, so I'm going to type that in. And this will give us how many people are actually in line at times 300. So we have 80 people. All right, so there are 80 people in line at time 300. This is one of these problems where we used part A in part B, and now we're going to use part B in part C. Part C says for times greater than 300, what is the first time that there are no people in line for the escalator? All right, well, we're starting with 80. There's 80 people in line at times 300. No one else is getting in line. For times bigger than 300, that rate went to 0. So I don't have to add on anybody, but we're going to subtract, again, 0.7 person per second. So minus 0.7 t. And I'm going to set that equal to 0 because it says we want no one in line. So what is the first time that there's nobody in line? So there's 80 people at times 300, and they're leaving, so I'm subtracting off 0.7 per second. So that's time. So I'm going to subtract over the 80. Negatives are going to cancel, and when you divide, let me just type that in real quick, you get 114.285 seconds. Or you could round it up to 0.286. This is what I got when I typed it in, 114.2857. I like to truncate, so I'm just going to do the first 3. Now, here's what kind of gets me on this question. And if I was rushing, I would have missed this, to be perfectly honest, if it was me taking the test. That is how many seconds went by since 300 seconds. Remember, we had 80 people at times 300. So you have to add on 300 to that. So it would actually be time 414.285 seconds. So again, we were starting at times 300, and then 114 seconds went by until that time. So you have to add on the 300 seconds from the first part. Right, then part D, for times 0 to 300, so we're back to that interval. At what time is the number of people in line a minimum? So this is going to be a candidates test. We want to check our endpoints and our critical points. This always shows up on the AP exam as well. They always have you do a candidates test. So I'm going to write an equation for the number of people. And it's going to be really similar to what we did in part B. I'm just going to kind of use variables for it. So the number of people is the initial condition, that's how many we started with, plus how many got in line. So how much we accumulated from 0 to whenever. And then minus the 0.7 people per second. And I use X for the variable because we had T in that function. You can call them all T, they're not going to take off for that. I just called it a different variable because I already used T there, so I called it X. So that's people, it's what you started with, plus how many got in line, minus how many left. Now your critical points will be the derivative. So I'm going to call this like people prime, your derivative here. 20 is a constant, so that's going to drop out. Derivative of an integral cancels, so it's just going to be that R function. And then derivative of 0.7x would just be 0.7. We're going to set that equal to 0 to get our critical points. So critical points is derivative equals 0. I'm going to add over the 0.7. And then I'm going to pick up my calculator for this. So we're going to put that R of X function, which is that like horrible thing, that's going to go into Y1. All right, so that horrible function goes in Y1. 0.7 goes into Y2. I'm going to make the window 0 to 300. I'll leave this negative 10 to 10. I'm actually not sure really what I'm going to need that to be right now, but they gave us the window 0 to 300. And let's see what we have got. Oh, you know what? I am going to need to really bring that window in because one of my equations is 0.7. That's going to be really teensy tiny. So actually, let's make this be negative 2 to 2. I wasn't thinking about that. One of the equations was 0.7, so that's going to be real small. I'm going to make my, you could even make it negative 1 to 1, but it's going to need to be a lot smaller than it was. All right, so there we go. That's better. All right, so I'm going to calculate the intersections. So it is second trace. We're going to calculate intersects. It's going to ask you first curve, second curve, guess. You can just hit enter for first curve and second curve. For guess, it's going to give you the one that it's closest to. So I'm going to do them in order left to right. So I'm going to make that be my guess. So we have 33.013 as one of our critical points. And we're going to need to reuse that value. So I'm going to need to store it. So before I calculate the other intersection, I'm going to quit out of here. And the way you bring it back is hit X, enter. And then you're going to store it. So store alpha A, enter. So you hit X, enter to bring it back. Store alpha A, enter will store that. So I've got that one stored as A. And now I'm going to go back and calculate the other one. So I'm going to go back to the graph, calculate intersection, first curve, second curve, and then guess. I'm just going to move the cursor over to the other one, and it'll give me that one instead. So 166.574. And I'm going to store that one as B, because I'm going to need to reuse both of these answers. So I'm going to be able to copy paste them. So I'm going to quit out of here. To bring it back, you hit X, enter. and I'm going to do store alpha B, enter. So I have one of the critical points stored as A, I have the other critical point stored as B, and we're going to do a candidates test. And our endpoints are 0 and 300. Our critical points are this A and B value. I have them stored, so I just wrote A and B. And you're going to plug this back into this original equation for people. So if you were to plug in 0, integral from 0 to 0 would be nothing, and then it would be minus nothing. Your initial condition was 20 people. So we're starting with 20, and then I'm gonna need to type this in for the others. Now you really only need to do it for one of these, and then you can kind of redo it for the other two. So this is gonna be obnoxious to type once, but after that I'll be able to bring it back. So 20 plus integral from 0 to A, oh, whoops. So integral 0 to A, and then one more time, I'm gonna have to type this really awful function. All right, and then it's minus 0.7 times whatever you want to plug in, which in this case, I want to do alpha A. So that gives us 3.803 for that one. And then when you go to do B, you can just go up and bring that back and just change all the A's to B's so that you don't have to type it all over again. So I'm going to change that to a B, and then this other A that's on the upper boundary here, I'm going to change that to a B. All right, and so that one gives us 158.070. And then once again, I'm going to bring it back again and change the B's to 300s. And so that gives us 80. Wait, that shouldn't be 80. Hold on a second. Oh, wait, yes, it is. We already did that from up here. Sorry, I knew that was going to be 80 people. I shouldn't have bothered typing it again. We already did that one. Oh, well. All right, so did this ask for a maximum or a minimum? Let me look back. At what time is the number of people in line a minimum? To the nearest whole number, find the number of people at this time. All right, so we want the minimum. So minimum is, and we'll round to the nearest whole person. So that would be this 3.8. So we'll round that to 4. So minimum is 4 people at time A, which was this 33.013 seconds.